A model estimates that a newborn elephant weighed 310 pounds and gained 4 pounds per day during its first 60 days. The model is written as f at x is equal to a plus bx. What is the value of a? Okay, well, just because it's written differently, that shouldn't freak us out. We know that this is still in the form of a linear function. Y is equal to b plus mx. You should be able to recognize that the letter right beside the x represents the slope, or the rate of change. Okay, well, the key here is that rate of change, right? Just by listening to what that sounds like, or the words themselves, we're talking about by what value do we change? The rate of change. Well, they're telling us. They're saying that this elephant gained 4 pounds per day. So every single day added 4 pounds. So if 1 day passed, that's plus 4 pounds. 2 days passed, that's plus 8 pounds. 3 days, that's plus 12, and so on. That is our rate of change. Okay, so they're basically asking us to come up with this equation so then we can realize and recognize what the value of a is, right? So let's list down everything we know. So given to us is that the elephant weighed 310 pounds initially. Okay, then it gained 4 pounds per day, so plus 4 pounds per day. This, again, every time we see the word per or each or something like that, this means that the slope, m, is equal to 4. That's the rate of change. Every day we increase by 4. During its first 60 days, and they're just telling us how many days passed. So we say 60 days passed. Then we have the model, and what is the value of a. So let's come up with our own model so then we can determine what a is. Okay, well, initial value. I feel like it's easier to see this as a graph. So when time is 0, again, this will be the number of days, this will be the weight. When time is 0, meaning no days passed, we have 310-pound elephant. Okay? Now, each day that passes, we gain 4 pounds. So 314, and then 318, for a second day. So, right, there's an incremental increase here of 4. And as we connect them, we'll get something linear like this. Well, if we recall, the standard form tells us that b is the y-intercept and m is the slope. Well, we already know what the slope is, right? We talked about this, the keyword per, whenever we have each, right? We're saying per day, each day. Okay, now the y-intercept, again, just by graphing it, we can see that's the initial value, 310. And the key thing is that whenever you're dealing with a linear function, any initial amount of something, so started with X amount of money, or started with X pound weight, right? Anything like that, that's going to be your starting point when 0 time or the X value is 0. So that's going to be your initial value or your y-intercept. So our y-intercept is 310, our slope is 4. So then f of x is equal to 4x plus 310. And if we match that up to the equation here, f of x is equal to bx plus a, our a value is equal to 310. A tree was 7 feet tall when planted and grows 2.5 feet per day. A model is defined as h at t is equal to a plus bt, where h at t is the height in feet and t is time in years. What is the value of a? Okay, same idea as before. Keyword here, right? Per year. This means that this is our slope. This should be like a ding ding in your head, right? Like per year means that our slope is 2.5. So this tree initially starts at 5 feet tall. And then every single year it increases by 2.5 feet. So again, if our tree is this height at birth, right? 1 year later, the tree will grow to be taller by 2.5 feet. So the difference between the heights is plus 2.5. And this will continue every single year. So to year 2, right? Now we're going to get even taller. So the rate of change is 2.5 because now we'll be at 5 plus 5 feet in the second year. Okay? So again, y is equal to mx plus b. We talked about b being our initial value, m being the slope. So y is equal to 2.5 x plus 5. We relate that to this here. Well, we're using h at t, y being the height. A plus bt. Notice that we're using t instead of x. Remember that t is always time, and it can be used as x. It's always going to be our x-axis, right? If this is x, then we're going to say t for time, and then h at t is here. This graph looks like this for reference, with a slope of 2.5. So then, matching that up, we can say h at t is equal to 5 plus 2.5t. Therefore, they're asking for the value of a is equal to 5.